Okay, so what we have here, let's shift gears. Let's do the multiple choice assignment. I will live a longer life and be happier if we do that. So let's go ahead and go to the reading, just so we make sure we got this pulled up and we can answer some questions if we want to. Um, Most of these are going to be pretty easy to find, I believe. Let's go through it and see. Non-silicate minerals are divided into groups based on what? That's going to be very early on. Um, Go down here, find your non-silicate part. Wait, where am I? Might have been on the right page. Didn't go over. All right, now we're there, and we're all happy, and everything's okay. Let's see. Silicates. So they talk about silicates here in this chapter where they're classifying it. So in this one of these first two paragraphs right here, they're going to tell you what you do to classify different silicate minerals. Actually, sorry. First question asked about non-silicates and not silicates. So go back over here. Non-silicates are going to be a little bit further down. So non-silicate minerals can be divided into 6 additional groups, and they're going to base that off of probably what type of elements are inside. If you look at the names, carbonates, halides, oxides, sulfates, sulfides, those are all based on elements in the periodic table. Carbon, oxygen, sulfur, those are probably going to be how they're kind of arranging it. So that should get you going with number 1. Number 2, silicate minerals are composed of what? And we kind of went over that with the exploration here. Silicate minerals always have to have this silicon-oxygen tetrahedron. It's got to be SiO4, has 4 oxygens around a central silicon. That's what makes a silicate a silicate. So if it has that, it's a silicate. If it doesn't have that, it's not a silicate. Which is a class of non-silicate minerals. So go back to your chart over here. They list your non-silicates right here. So just match up one of those answers to this list of non-silicates, and you should be able to answer that question. Did you wash your hands?
Yeah.
Okay. No, I'm just making sure. Since we're going back to kindergarten, you gotta make sure you wash your hands and use hand sanitizer. Okay. Yeah. We're not doing the explanation. We switched gears to multiple choice because the explanation was terrible.
We just like dick.
Yeah. Which statement best describes the essential characteristic of non-silicate minerals? So what is the essential characteristic of non-silicate minerals? The non-silicate is probably going to be the key part here. If it has silicon and oxygen, it's a silicate. Everything else that doesn't have this is a non-silicate. And so that's going to be your defining feature right there. Silicate minerals are divided into classes based on what? So now, that's what I thought the first question was, and they got to it. They're dividing silicates into what? And so basically when they talk about this, how the silicate minerals are going to be divided is going to be the first sentence of this second paragraph here. So they talk about what those tetrahedrons are doing, and that's how they split up your different silicate minerals into different groups. Number 6, which mineral is a silicate? Just kind of look through the list and see which one. You might have to look up the chemical formulas if you want and see which one has silicon and oxygen. The other 3 should not. You might also be able to find them all on this chart down here towards the bottom. Yeah, I think all of them are going to be on this chart. And so you should be able, they have examples over here on the right. You should be able to find the silicate in the examples and the non-silicates in the other examples. So, number 7, all minerals are, that's going to be part of these top 4 up here. All minerals have to be these 4 things. So read through the answer choices, see if they match up or if any of them match up with those 4 things. That's what they're looking for there. What are the 2 main classes of minerals? The two main classes are going to be your overall big groups. Those are going to be your silicates and non-silicates. Yeah, those are your two classes, silicates and non-silicates. I don't know if they say that outright, but those are your two big groups. And then let's see. Minerals are described by their what? So how do we describe minerals? And this is a very simple answer. Chemical composition, physical characteristics, both A and B or neither A and B. It's more than likely going to be both, physical and chemical, because I need to have a chemical formula, but that's not the only thing. I got to know that it's solid. I got to know that it has a specific crystal structure. I got to know that it's inorganic. And so the physical characteristics count as well. Number 10, which is the largest group of minerals out of the ones here? So total silicates are your biggest group. Silicates are by far the most common. Out of these four, which are going to be the most common, the largest group of minerals? Let's see if they tell us this. It's going to be down here in the non-silicates, which that doesn't really tell us. Chemical groups of minerals, the pyramid of nature, micas, mining. Nope, doesn't have anything. If I had to guess, what are my answer choices? Let's see. Carbonates, native elements, non-silicates, or oxides, all non-silicates. Yeah. It's the largest group of minerals has to be the non-silicates. And here's why. Non-silicates is like an umbrella term that includes all of these other things. So a native element can be a non-silicate. A carbonate is a non-silicate. An oxide is a non-silicate. So non-silicates has to be the right answer because it includes all the other ones, unless I'm just missing something here. Number 11, which mineral property is determined by chemical composition? Mineral property determined by chemical composition. We actually kind of talked about that with the quartz. We talked about what happens if you add SiO2 to quartz, if you add iron to quartz, which is SiO2, it changes from a clear color to a purple color. And so the property of the chemical is defined by the color. Every element, not every element, but most elements have a different color that's unique to just them, like gold. Nothing else looks like gold. And so the chemical composition is what affects the color. Which is a surface mining method. So surface mining, you're not digging a hole down into the ground. You're just mining right off the top. And so they talk about surface mining here in this last paragraph. They have a couple different versions here. So I know that I saw one of them in the answers.
Mr. Bailey.
Yeah.
Number 11 is all the above. It's not just color.
Hardness, crystal form. Okay, fair enough. All the above. That makes sense. I guess.
I submitted it and
That's
got it wrong.
it's a little bit of a stretch, maybe. Yeah. Here's why I'm going to argue with that. And this isn't what I'm not arguing with you. Hardness. Hardness is why. What's the hardest thing? Diamonds. And what's the chemical composition of diamonds? It's literally just carbon. It's just carbon. There's nothing else in there. What is also just carbon? Graphite, like your pencil lead. Pencil lead's not very hard. Diamond is extremely hard. They both have the exact same chemical composition. Yeah. And so I get what they're saying, and they're kind of right, but it's not also like 100%. And so, yes, do go ahead and put all the above. That's probably what they're looking for, but that's maybe not the best way to frame the question, I guess, is what I would say. So, yes, so we got the not exploration, we abandoned the exploration and did the multiple choice assignment. If anybody at home has any questions, please just let me know. Send me an email. May everybody make sure that you did this and submitted it. Don't be getting zeros early on in the 6 weeks. And everybody have a nice weekend.